Hello everyone, my name is Sandro. I'm currently research assistant at the Software Quality and Architecture Group of the Institute of Software Engineering at the University of Stuttgart in Germany. In this video, I present to you our tool demo paper Gropius, a tool for managing cross-component issues. However, before we start, let me give you a brief overview of a motivation scenario and the problem statements we are tackling with Gropius. Let me introduce you to the developer Bob, who works for a company which builds a webshop as microservice architecture. Bob is responsible for developing the order service. The order service should invoke an interface's functionality of a shipping service which is developed by an independent team of another company. One of their developers is John. As you can see, John thinks of himself as an artist. Bob and John do not know each other. Since the services of this component-based architecture are independently developed, each service manages its issues in a separate issue management system. Therefore, the order services issues are managed in a GitHub repository, while John manages the shipping services issues in a Jira project. One day, John gets a brilliant idea to write some source code for the shipping services interface. However, his implementation is a bit buggy. Since the order service invokes this interface's functionality, the bug propagates to the order service. Bob is annoyed about this new bug in his service and looks for the origin of it. He finds out that the bug is dependent on the other bug of the shipping services interface and finds a bug report for it. However, since both services manage their issues independently in different systems, Bob cannot link his bug report semantically to the shipping services bug report in the Jira project. Fortunately, there's Gropius, an integrated issue management system which can manage such cross-component issues and propagate changes to the underlying issue management systems of the services. Let us now take a look at a demo of Gropius and how Bob can use the tool to manage cross-component issues. After logging in, Bob can create a new project with the New Project button. He created a webshop project and goes to Issues. As you can see, there are no components yet. Bob creates a new component with the New Component button. He provides a name for the component, in our case the order service, a description, who the owner is. Then he also provides the provider of our issue management system and the name of our issue management system repository. After creating the component, it is shown in the graph, where he can drag and drop, resize, and take a look at it. Bob created two components, now he wants to connect them. Via drag and drop, he can create an interface for the shipping service. He provides an interface name, which is the description of which interface we have here. Per drag and drop, he can move the interface, and also per drag and drop, he can connect the order service to the shipping services interface. After creating more components and connecting them to each other, he can filter in the graph for feature requests or bug reports. He can click on an interface to show the interface node, to create a new issue for the interface, or take a look at the interface, that's his bugs. He can also click on each component to show all bugs or create new bugs. As you can see, this works for every component. Bob creates a new issue, in this case a bug, for the accessing of the shipping services interface. He chooses the bug type and gives a description. Then he creates the bug. After creating the bug and providing the link to the other bug, Bob can move the graph around and sees the complete application in the minimap. The newly created issue is propagated by Gropius to the order services GitHub repository. You can see the bug here. By clicking on the bug and looking at the details, you can see metadata which is interpreted by Gropius, for example a bug, or the information about the related issue. Now Bob can see in the graph the dependency of his newly created bug report to the bug report of the shipping services interface, and its dependency to a bug report in the inner core of the shipping service component. To summarize, Bob and John can manage their cross-component issues with Gropius in a simple graphical notation. It allows them to visualize dependencies between multiple components and issues directly, instead of only having a textual relation. Gropius synchronizes every action they perform to the underlying issue management systems and backwards. Let us take a quick look into the architecture of Gropius. Apart from user and project management functionality, the essential part is the cross-component issue modeler, which implements our graphical language to model cross-component issues. The front end communicates via GraphQL with the backend. In the backend, there are controllers for managing user, project, and component data. The tool uses a PostgreSQL database to store the necessary information about the users, projects, and components. Gropius acts as a wrapper across conventional issue management systems. There's an abstract issue management system adapter, which offers a uniform interface to manage issues. Adapters for the specific issue management systems extend the abstract issue management system adapter to allow Gropius propagating the operations on the issues to the underlying issue management systems. This way, using the adapter pattern, Gropius can handle every issue management system an adapter exists. Simply another adapter must be implemented to support a new issue management system in Gropius. Depending on the issue management system, Gropius uses the user's access token or credentials to authenticate, or even acts as an app for the issue management system. So, perhaps you now might think, there must be another solution to this old and essential problem. And of course you're right, there are solution approaches which I want to give you an overview. However, keep in mind that in our motivation scenario, both services managed their issues in separate issue management systems. One was GitHub and the other was Jira. Due to time reasons, I only can present the most promising solution approaches proposed in related work, Jira and Redmine forums. One solution is to create a joint Redmine task for all projects and subtasks for the respective affected projects. However, this solution is only feasible if all projects are handled in the same Redmine project. In such a case, you can additionally use Redmine's related issues, which can model dependencies between issues of the same project. Another proposal is the structure plugin, in which Jira data, such as issues from multiple Jira projects, can be managed and filtered together in a spreadsheet-like UI. A significant disadvantage of this plugin is that ownership permissions are required for each project, which is usually not applicable in component-based systems. The Jira plugin Backbone Issue Sync allows the synchronization of an issue across multiple Jira projects. A similar plugin is the Multi-Project Picker, which removes the limitation that an issue can only belong to one project. Instead, an issue can be assigned to multiple projects using comma-separated project names in a form field. However, both plugins are limited to Jira. Other issue management systems like GitHub or Redmine are not supported. All presented solution approaches suffer the fate that they cannot handle components with different issue management systems as given in our problem statements or similar scenarios. Therefore, none of these solution approaches is sufficient enough for us. Okay, thanks for watching. I hope you liked our solution approach with Gropius acting as a wrapper across the conventional issue management systems. Please let me know what you think about it. See you all, goodbye.